Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn more about quadratics, modeling quadratics, applying it in real life application. At this point, we know that the graph of quadratic is called parabola. One is open downward, one it opens upward. This point is called the vertex, and the vertex can be a representation of its maximum value and its minimum value. If the leading coefficient is negative, it opens downward, and that gives us a maximum value. And if it's A, or the leading coefficient is positive, it gives us a minimum value. And for us to find the vertex, we have to use a formula x equals negative b over 2a that represents as the axis of symmetry. And then we plug this back to our function in order for us to find the y-coordinate of the vertex. Let's go ahead now in our first example. A farmer is constructing a rectangular fence in pen to contain rabbits. There is 120 meters of fencing. Determine the maximum area. Okay, we're going to find an area of the pen and dimension that result in the maximum area. So in this problem, a farmer needs to fence a rectangular area, say that's the area. There are two widths and two lengths. And according here, there's a 120-meter fencing. So the formula for perimeter is twice the length plus twice the width of a rectangle. And in this case, there are really two lengths and two widths. So the P here is 120 equals 2L plus 2W. We will need to solve for one of the variable because we're going to find its value and apply it to the area. So in this case here, you can choose. You're going to solve for the length and the width, whichever is easier for you. I'm going to solve for the length. I'm going to divide everything here by 2, by 2, by 2. That gives me 60 plus L. This will give me 60 equals L plus W. And then move the W to the other side. That gives me 60 minus W is equal to the length. And that's my length. And we know that we're finding for the maximum area. In order for us to find the maximum area, we know the area is length times width, right? We will plug in the length right here, 60 minus W, and the width is still W. You're going to distribute the W here. That will give you the maximum area. So 6W minus W squared. Or writing it in a standard form will be negative W squared plus 60W equal to 0. Now, this is our equation. In order for us to find the equation, or in order for us to find the maximum area, take note that the maximum value in a quadratic is the vertex there. Can be found in the vertex, especially if A is less than 0. On this case, A is negative 1, so we will use the formula x equals negative b over 2a. And that will give us negative b is negative 60 over 2 times negative 1. Therefore, the x there, or the w, this should be w here. The w here, because we're looking for w there will be negative 60 over negative 2, or w is equal to 30. Should be w, okay? So the width has to be 30. And then we're going to plug in 30 to the w here. That will give us L is equal to 60 minus 30. So therefore, the length is also 30 meters. Now, to find the area, L times width is 30 times 30 will give us 900 meters squared. A farmer is constructing a big pen and using his barn wall as one side of the pen. If he has 32 meters of fencing and wants to use it all, write a quadratic function that models the area of the big pen and use it to determine the maximum area of the pen. So Number one is always draw. So let's say this is the barn, red barn. And one side will be used for as part of the border or the fence, and this will be one side of the fence, and this one side of the fence, and this one here. So let's say this is the width and the length. So in this case here, we're gonna use the 32 meter for fencing, 32 meter of fencing for two width and one length. So therefore, our formula for perimeter is now 2W plus L, wherein the perimeter allocate for the fencing is only 32 meters and 2 width plus L. And obviously, again here, it's easier to solve for the length because there's only one length. So L is equal to negative 2W plus 32. And we know that W is equal to W here. We're gonna find for the area of the pig pen. So therefore, we're gonna apply the formula area is length times width, and we know that the length is negative 2W plus 32 times W. So therefore, our equation here will be negative 2W squared plus 32W. And that's our this our equation. Since we're trying to find the maximum area of the pen, we're gonna apply the formula for axis of symmetry, which is not x, it will be w because we're solving for w here, negative b over 2a. And on this case here, negative b is negative 32 times 2 times negative 2. And that will give us negative 32 over negative 4. That will give us 8 meters for the W. So W is 8 meters. So this will be equal to 8, and that will be equal to 8. Now, we're going to plug in the 8 right back there to find the length. So length is equal to negative 2 times 8 plus 32. That will give us L equals negative 16 plus 32, or the length is equal to 16 meters. So if the question was the dimension, it will be 8 meters by 16 meters, the dimension of the pig pen. But the question here is what's the maximum area? If that's 8 here and this is equal to 16, 8 times 16 will give us 8 times 16 is going to be 128 meters squared is the maximum area of the pig pen. Kaboom. All right, let's go to the next problem. You have 600 meters of fencing and a large field. You want to make a rectangular enclosure split into two equal lots. What dimension would yield an enclosure with the largest area? Okay. All right. So on this field here, we would like to split them into two equal parts or equal lots. So we're gonna split it, and that makes us a width and a width right here. There will be three widths here, and the entire side will be length and length here. That makes our 600 meters to be used in all of them, and therefore our perimeter now will be there are three width and two length, wherein our perimeter is 600 3W plus 2L. Now we will solve for one of the variable. This time let's solve for W. Okay. So 600 minus 2L equals 3W. Divide them all there by 3, by 3, by 3. That makes us 200 minus 2 thirds L equals W. And that's our W. And therefore length is equal to length. We know that. Okay. Since the area is length times width, we will multiply the length of the width. That gives us 200 minus 2/3 L times L. That gives our maximum area formula will be 200 minus 2/3 L squared. That will be our equation. If you write in standard form, it will be negative 2/3 L squared minus plus 200 L equals 0. Either of these two is correct. Now, since we're looking for the largest area here, and we're looking for the dimension of the one that will lead to the largest area, we're going to find again the formula. This time it's not x or nor w, it will be L because we're solving for L. L equals negative b over 2a, wherein my b here is negative 200 and my a is negative 2/3. That will give me negative 200 over negative 4 over 3. Or using my calculator, will give me 200 divided by 4. That will give me the length of 150 meters. Now I will substitute that 150 right here on my equation for W. That will give me 200 minus negative minus 2/3 of 150. So 2 divided by 3, 200 minus. That will give me 100 meters. So therefore, this will be 100, 100, 100, and this will be 150 and 150. Okay, meters. They're all meters there. Okay, so the dimension will be 100 meters and 150 for the entire field. All right, that will give you the maximum area here. Okay, the maximum area for the entire field will be 100. Okay, we know that area is length times width, so 100 times 150 is going to be 15,000 meters squared. Okay. All right, and that's how you model quadratics and finding the maximum area. I hope you learned something. As always, kaboom!